Christian is in the kitchen baking cookies.
The rent for the baking equipment is $5. The rent for the space is $15. The electricity is $3.
These represent the fixed costs that are not affected by the quantity of output.
Eggs cost 50 cents.
Milk is $2.
Butter is $2. And flour costs $3.
These are all accounted for in the variable cost, which is affected by the quantity of output. All these ingredients will make one cookie.
I'm not working for free.
The cost of labor is $3. To bake up to 3 cookies, it will take 2 hours.
All these represent the various costs that are affected by the quantity. The total cost of inputs could be found by adding the fixed cost and the variable cost together. It will cost $36.50 to produce one cookie. It is important to note that the fixed cost is a sunk cost that will not affect Christian's decisions of continuing working because the money paid cannot be returned.
I wonder how much it costs to produce one cookie.
As seen, the total cost of production will continue to rise as output increases. The average fixed cost will be a downward slope, showing the economies of scale because there is no change to the fixed cost. The average variable cost will increase every 3 cookies because of labor.
In graph form, it is seen more clearly that total cost will continue to climb up. The average total cost will always be above the average variable cost and average fixed cost. The average variable cost is descending downwards. Though average fixed cost is usually disregarded because it's a sunk cost, it slopes downwards also.
As informed below, labor is worth $3 per hour. It takes 2 hours to produce a batch of cookies that consists of 1 to 3 cookies. Thus, labor for up to every 3 cookies will be $6. The marginal product of labor is a constant 3 because every 2 hours has a maximum output of 3 cookies and is a constant quantity change of labor and cookies as shown on the production function chart above.
The graph shows the production function. As more labor is put in, there will be more output produced till diseconomies of scale, where the curve will start to go downwards. But in this case, there is a constant marginal curve of 3 because labor is calculated by hours and only Christian will be working. So, on the graph, it is seen the curve goes up in increments of 3.
Selling the cookies for $5 each, how do I know when to stop making cookies?
Oh yeah, when producing, I have to make enough cookies so that the marginal cost equals the marginal revenue because of the optimal output rule.
Christian will produce up to the optimum output rule because it is the profit maximizing point. To find the point, Christian needs to find the marginal revenue and marginal costs, additional revenue earned or extra cost for one more unit. Finding both these will also give the marginal profit, which is the profit earned by selling an additional cookie. This will help to determine his quantity.
Because the marginal cost does not intersect with the constant price of $5 represented by marginal revenue, Christian will produce to where average total cost intersects marginal revenue at the lowest point of the curve, which is also called the minimum cost output. This will cut losses in the short run. Also, the total revenue and marginal revenue are a horizontal line that is constant. Total revenue goes in increments of 5 because each cookie sold is $5, while marginal revenue is a constant $5 for every additional cookie sold, would bring 5 every quantity.
The utility people get is the price at which they will purchase it. If not, they will not purchase the cookie. The benefit of buying that cookie is worth $5, as so on in increments of 5 because the price is $5 as the quantity purchased increases. Because I'm producing at a loss, so I'm not going to produce any cookies at all.